Hi guys, today's Leetcode daily is find all possible recipes from given supplies. So we are given n different recipes and these names we can get from an array named recipes. Now to make these recipes we'll need some ingredients. So for each recipe we can get ingredients from 2D vector ingredients. Now we have supply array which will contain all the ingredients that we initially have. But here the twist is that this recipe will need ingredients. Some of that ingredients so we can get from supply, but some ingredients will be some recipe itself. So we have to give list of all the recipes that we can create and we can return the answer in any order. Now we'll see example to understand this question in a better way. Like here we have recipes of bread, sandwich and burger. To make bread, we need ingredients yeast and flour. So this we'll get directly from the supply. We are able to make bread. To prepare sandwich, we need bread and meat. Bread we'll get from recipe. First we'll prepare bread and meat we'll get directly from supply. So we are able to make sandwich also. Burger needs sandwich, meat and bread. Sandwich we'll prepare from recipe. Meat we'll get from supply and bread also we'll get from recipe. So we are able to make this burger also. So we are able to prepare all these three recipes. So we'll return all of them as our answer. Now we'll see approach. First we'll prepare that recipes for which we can get all the ingredients from supplies. After that, we'll prepare those recipes which needed other recipes as ingredients. As simple as that. So whenever there is such dependency, then we use standard concept toposort, which is linear ordering of vertices u and v such that u comes before v. Now we'll see like revise what is toposort. So this is toposort by using Kahn's algorithm. So first we'll find in degree of all nodes. In degree means number of incoming edges to a node. Then we'll push all the nodes with in degree 0. That means all the nodes which don't have any dependency on any other node. We'll like push them. Now we'll start traversing in the queue until queue is not empty. We'll remove top element and store it. And for now, every adjacent element of this node will decrease in degree by 1. And if during this time in degree of any node becomes 0, we'll push in the queue. So this is standard topo sort by Kahn's algorithm. I have given just for revision. Now we'll see like how we can use this in our question. So we'll make graph with each recipe as node. Now we'll connect node with edges according to dependency. Like here, sandwich needs bread and burger needs both sandwich and bread does not need anything. All the ingredients we'll get supply from supply. So if we see like in degree of bread is 0 as no incoming as is there, in degree of sandwich is 1 incoming as is there, and burger is 2. So first we'll put in the queue bread since its in degree is 0. Now we'll remove bread and we'll store bread in our answer. After that, we'll move all its adjacent nodes. That is, we'll move to sandwich and burger and decrease the in degree by 1. So in degree of sandwich will become 0, whereas in degree of burger will become 1. So since in degree of sandwich is 0, we'll push in the queue. Now again, in the queue topmost element is sandwich. We'll remove it and we'll store it as our answer. And we'll traverse its adjacent element. So it's now burger only. Now we'll decrease in degree of burger by 1. Now it's in degree 0, so we'll push in the queue. And next time we'll store burger in our answer. So this way we'll get all the three bread, sandwich and burger in our answer. So we'll apply toposort and find answer. Now we'll see the code for better understanding of the implementation part. So we initialize n with recipes.size. We have taken a set named supply set. In this, we'll store all the ingredients that we can get directly from the supply. This we are doing so that in future, whenever we want to know that this ingredient is present in supply or not, then we can get. And I have also taken unordered map recipe to index. This, since I am storing in nodes only integer value, so I have this mapping will be needed. This is standard adjacency list of the graph where we'll store graph. Adjacency list, in adjacency list for every node we are s- storing which all are adjacent nodes. And this is in degree vector where we'll store in degree, which means number of incoming nodes to that node. Now we'll just traverse in recipe and just store our mapping. Then we'll traverse in supply, and in supply side we'll store all the ingredients that we can get from supply vector. Now for every recipe, we'll see what all ingredients are needed. If that ingredient is not present in supply, but that is present in recipe, so our current recipe is dependent on that recipe. So we'll make a edge from that recipe to our current recipe. And since our current recipe is dependent on something, we'll increase its in degree by 1. If this situation arrives that the ingredient is neither present in supply set nor it is present in recipe, so we cannot make only our current recipe. So we'll do in degree equal to -1 so that we never process this node. Now we'll apply like a standard topo sort. In this answer vector, we'll store our answer. We'll traverse for each node, and we, if for any node is, if it's in degree 0, we'll push it in the queue. Now every until the queue is not empty, we'll take the first node, and this will we'll push it in the answer. And for its all the adjacent nodes, since this is processed, we'll decrease the in degree by 1. And if for any adjacent nodes in degree becomes 0, we'll push it in the queue. So when this loop is completed, our answer vector will contain all the recipes that can be prepared successfully, and we'll return answer. Now, if we talk about time complexity, then this loops for n times, that is big O of n. And if supply has k ingredients, then it will run for big O of k. And if total ingredients across all the recipes are m, then this will run for big O of m. Now this is a standard topo sort. For topo sort, we have time complexity b plus e, where vertices will be equal to n and edges is proportional to this number of ingredients, that is m. So it time complexity is big O of n plus m. So overall time complexity will be big O of n plus m plus k. We talk about space complexity, then there are k elements, so this will be big O of k. There are any elements, so recipe to index will be big O of n. Here we have n plus m elements, so it will be big O of n plus m. In degree is also big O of n. This q is also big O of n, and this answer vector is also big O of n. So overall space complexity is big O of n plus m plus k. If you have understood this question, then please like, share and comment on this video, and subscribe my channel for more such videos. Thank you.